So far, we've talked about adding and subtracting vectors and also multiplying by a scalar. But what happens if we have two vectors and we want to multiply them together? Well, one of the ways that we could multiply two vectors together is known as the dot product. So let's suppose we have a u, which is a three-dimensional vector, and a v, which is a three-dimensional vector. The dot product of u and v is just u dot v, and you multiply each of the components together and add them all. This dot product will produce a scalar, hence why the dot product could also be known as the scalar product, but we also call the dot product the inner product in some cases. So what are some properties of the dot product? Let a, b, and c be vectors, and d be a scalar. Then a dot a is going to be the same as the magnitude of a squared. A dot b is going to the same thing as b dot a, so we have commutativity there. And then a dot, the vector b plus the vector c, is the same thing as a dot b plus a dot c. Also, we have d times the vector of a, the scalar d, of course. Dot b is going to be the same as d times a dot b, and the same thing as d times the vector b dot the vector a. So slight change from here. Obviously, this one is the same as this. And also, 0 dot a is just going to be the 0 vector. As a quick example, if u was this vector and v was this vector, what would be u dot v? Well, we multiply the components, so we have 1 times negative 3 plus 2 times 2 plus 3 times 0. We have negative 3 plus 4 plus 0, which is just equal to 1. So the dot vector of u, the dot product of u and v would just be equal to 1.